Hello everybody, welcome to another episode of Stuff and Things. Previously here on Stuff and Things, we made this water collector thing, which is, it wasn't working at this point. It was kind of working, but it was like super slow, and I figure this is due to the fact that we're using such a small collection apparatus. But I also eventually realized that this liquid can actually evaporate out of the collection apparatus and back into the system, so it's really not going to be super efficient. However, if I were to add a pipe going through the bottom of this system, allowing me to take out liquid very quickly, that would actually allow us to not have it evaporate back into the system. I also wanted to make things a little bit better, make this area into the official new zone for doing things. As I like having the water collector pretty close by, it feels like a kind of enclosed space, kind of. So I decided to build a workbench as fast as possible. We must make haste, so this video is not 10 years long after all. Also, the board was muddy because it had been sitting in the dirt for a while. And this was rather annoying because I had it dirt side up, which is obviously bad. We don't want no dirt getting into our wonderful mixtures and concoctions. So from our last electrolysis experiment, we have some products, which I'm pretty sure this was bleach. I'm definitely sure of that. However, it had begun to actually sour, like the smell of it. It was not bleach anymore. It smelled more like electrical tape. So that's why I wanted to test it, because I had no clue what it was anymore. The reason it could have done this is, first and foremost, that the light, it was stored in a transparent bottle, which light is not good for bleach. It causes it to decompose. Also, it could contain metal ions, which, from the actual electrolysis machine. So here we're reacting the substance with acetic acid, and absolutely nothing happened. But then when I pour this into baking soda, of course something's going to happen, because, you know, acetic acid reacts with baking soda, of course, or sodium bicarbonate. I had also tested if it would react with baking soda prior to this, and it did not react, which was a plus in its favor, as bleach would not react with baking soda. However, bleach would react with acetic acid to form chlorine gas. So this test here is going to be a bleaching test, because it's bleach, right? It might be bleach, so we gotta test if it bleaches things. By that, does it remove dye? What happens when I pour it on paper? What does it oxidize a nail? See, these are all things that bleach would do. Now here I was questioning, is it because I just didn't add enough of this stuff to the actual acetic acid? And you see here that the actual color of the liquid changes. Now I believe this is due to a physical change rather than actually something chemical going on. As adding red to blue and getting green would be more of a chemical change, however, adding, what is it, like blue and yellow to get green is a more of a physical change. I mean, we didn't get green out of this, but you know what I mean, it's an analogy. But yeah, at the time I didn't notice that it kind of changed tint slightly, or whatever. Now, what I expected to happen when I poured the yellow stuff into the acetic acid was something along the lines of this. Now, ignoring the fact that we dumped a bunch of unidentified yellow substance into this acetic acid, what's basically happening is that the sodium bicarbonate is reacting here to make sodium acetate and also carbon dioxide, and I'm not really sure what the liquid is left over. It's probably just unreacted acetic acid and maybe water or something. I don't know. And don't quote me on this, but I think it's actually sodium acetate is actually edible, maybe, potentially, but I wouldn't go eating it. I don't know. Our next unidentified compound, cupric anode juice. I don't know why it's orange. I don't know why it's always orange when I use copper as an electrode, but for some reason it's always orange. The first test was to pour it into vegetable oil. So the result of this test is that basically it sunk to the bottom, which means that this copper juice is more dense than vegetable oil. And also it didn't mix, indicating a difference in polarity. Now the next test is to determine if it contains sodium hydroxide. This test involves sticking some aluminum in it. And I don't expect this one to react at all, as I think you actually need to have the solution be a little bit more warm for this to work. Maybe add some active heating. Regardless, nothing happened, so I just moved on. Now, arguably the most interesting test of this video is the fact that it made a piece of paper waxy. You'll have to see how it looks at the end of the video to understand what I mean, but I tested it by dipping some paper into it. Now, I'm not really sure what this means, but I'm pretty sure that if this was sodium hydroxide, it would just turn the paper brown, right? Maybe this is actually copper water. It's the water of the future. It's mineral Wasser. But we're gonna keep calling it copper juice. Or orange juice extra pulp. And then we have the acid or base tests, which basically just show that absolutely nothing happened at all. Which, with this, you would expect it to be a base, so it would react with acetic acid or any acid, really. Now back to those bleach tests we did earlier. The results are starting to show here with the apron actually having a bit of a bleach effect, as you can see later on here. However, I actually noticed that there were salt crystals forming here, which means that we have a very impure bleach solution, if it is bleach. And it still contains the electrolyte. I didn't actually crystallize that out, which I probably should have done. As well as this, the nail isn't actually being oxidized, which you'd expect it to be oxidized. Especially because this is salt solution. And really nothing is happening with the paper at all, it's just paper. Now back to the water collector, it's now nighttime. I was expecting rain to come overnight because it was calling for rain the next day, so it's gonna rain overnight, you know. But that's not the case, so we just wasted our time sealing it up for no reason at all. I mean, it's kind of a nice shot, you know. Well, you can barely see anything in this one. I should really put more time into making sure it's actually you can see. I also set out a carton so we could collect some water if it rains. This way we could pour in water for infinite amounts of water. We could just distill rainwater. Which, funny thing is, rainwater, although it comes out of the sky, is not distilled. It actually contains pollutants. So, rainwater could technically contain sulfur oxides, making it into sulfuric acid. Or soot, or dust, or I think even carbon. No, not really, I don't know about that one. I mean, I think it might actually be able to contain carbon oxides, but I don't know. Now, after a day, noticeable salt crystals had begun to form on the paper, but it also got contaminated with the orange juice, which did not evaporate from the notebook cover. The paper was actually waxy. And like I said, I don't really know why this is the case. I thought it would just turn brown or something. I don't know. Unless somehow we saponified the paper. We've turned it into a bar of soap, I think. Now this is something I noticed after the fact because I was just wondering what would happen if I shook it up, and interestingly, this actually just I don't know what's going on with this one. This is fascinating. It might have something to do with how dense this liquid is, but it also looks that it might just be like maybe it's doing some reacting or something. Now something similar with like this happens with milk. If you shake up milk, it doesn't go down right away. But with this, it goes down very quickly, which would indicate, like, I don't know. Don't really know. And with milk, it actually forms, like, large bubbles in it, whereas with this, it also forms large bubbles, which is the similarity why I'm thinking they're similar. You can also hear that it makes a very audible sound. Now, comparing this with water, you can see that water doesn't make as many bubbles that last as long. Water doesn't have much of a noise, but it does have some noise to it. And overall, there's a pretty great contrast between both liquids.